This is Racing to Green, and this is the third in the series on the Internet Smart Garden, and this is going to be when I'm going to go over how we are writing the code for the project. I actually had some issues with the project, so I've done some updating to it since I first built a couple first videos. Added a actual pump to the system as well because we weren't getting quite enough pressure. I wasn't able to actually get my rain barrels up high enough to use gravity feed for both beds once I got the second bed put in. But we're going to cover some of that and the code to make it all work. And I just want to start off with essentially looking at how cool I guess Arduino thinks my project was. So we're on the Arduino store page for the new Rev 2 of the IoT Internet of Things carrier. And if you scroll down, you'll actually see my project linked in their sales page. So they had a link to the actual hacker.io, hackster.io project that I had built. I haven't quite been able to get my Arduino page project to be approved yet, even though they're actually linking to it and put it in their blog, but still working on that too. But anyway, let's move into the code and start off with the actual variables and the cloud variables in the setup portion, and just going to go through these one after another. First one is the moisture setting, which is of course the important one. This is what the moisture sensor is reading and what turns the pump on or off. So you can see right now last value is 73. That's 73% soil moisture right now. The next one I added is pack voltage. Because I added the pump, I now have two small batteries that I have wired in series, still 12 volts, but with a little more amperage because I needed some more amps to actually run the pump. So right now that pack is running at about 12.362 volts right now. And the next variable is the set relay state. And this is where I can actually, with a button, turn the pump on and off. And right now it's set to using the sensor. I have to actually turn the sensor off first and then turn the pump on. Next one is temperature. That's 103 degrees out. One of the things I've also added since the project started, I think I may not have it in the other videos, is I added a small fan, a small 12 volt fan to pull some of the hot air out of the box. And next one is USB volt, and this is the voltage that's going into the IoT carrier, and then of course, well, actually into the Wi-Fi 1010 microcontroller. And then the next one is the use sensor, and this is the button that you click on to make it use the soil moisture sensor instead of manually turning it on and off. Because I was having issues with my Wi-Fi and actually uploading sketches, I added the Wi-Fi RSSI piece of code so that I can see what the carrier board is actually getting. And so that's the variables. I'll go through the sketch itself. And initially, these are the includes for the libraries that you have to add for using the IoT carrier and the Arduino Cloud. So you got the Arduino IoT Cloud .h, that's the library for that. The thing properties is the library for using the separate thing properties that carries all the variables, and also has your secrets within it too. They include the Maker IoT Carrier. That's the specific library for the carrier that I'm using. And then the Maker IoT Carrier start. And my first variable is an integer for the moisture pin. And I'm using A5. That's just what I'm plugged into in the IoT Carrier. And just calling that out. And then the calibration of the moisture sensor. Every one of these moisture sensors you get will have to be calibrated. I have this set for 12-bit, so it's basically 0 to 4095 is the span of the sensor sensitivity, and you have to find within that what dry is and what wet is. So right now I have the integer for air analog, and that's what it is at its dry state. So if you have it just sitting out in the dry air, right now to get to zero moisture, I have to set this to be 3540. And when it's in a cup of water, which is how you test it, this is the reading that I get it to 100% moisture at 1620. And the next one, we're defining the sensor A6, which is the voltage sensor that I'm using for the battery pack. And for that, I have a small board that measures the voltage on the board. And you're setting the V out and V in, voltage out, voltage in, to 0 at the start, and you're using the built-in 30 kilo ohm resistor in it, and the 7.5 kilo ohm resistor built into it, and R1 and R2 for the floats for that. And this is integer for valve relay. I actually can remove that. I removed this from I think the code actually. I was using a high and low instead of actually using the relay on, relay off functions. So I actually don't need that one, so that one doesn't have to be there. Void setup, we're starting the program, then the setup of the program. Initializing the serial port to 9600. And there's a little bit of delay to get that, get all that set up. And initializing properties. And then the first connection we're making is to connect to the Arduino Cloud. You're starting that up, so getting it to connect to the cloud. Excuse me. Set debug message level. This is pretty much a boilerplate code for all this Arduino Cloud. Print debug info. You can go into debug mode and check to see what kind of messages you're getting. Then we're starting with setting up the carrier case, which in this case I'm not using the standard Arduino IoT carrier case. I'm using the box that I have, which has got a clear cover on it, but I'm still setting it to true because this sets the sensitivity of the buttons. And I finally got all 5 buttons to work, which has been nice. I found I had to actually program them backwards from in the code, so starting from I think 4 down to 0. And I think anytime I did it the other way, from 0 to 4, I couldn't get several of the buttons to work. So then we're starting the carrier code to begin. Carrier display, we're setting the rotation to 0, setting its orientation. First one, we're starting with carrier relay 1 and 2 to close. We're starting the relays off as closed to start off with. For me, that's going to turn the pump off, and I don't want the pump running through the startup sequence if I don't have to. It's going to run for a little bit because it starts them all up based on how this works. Pin mode 3, this is for me, I'm shutting off, trying to save some voltage and some battery. It's just turning the backlight on the IoT carrier screen off. So we're setting pin mode to 3, out and setting it as an output. And then we're setting digital write of that pin to low, so we're turning it off. And this is the void loop code. This is the looping portion of the code. And this is what continuously runs. Arduino Cloud, we want it to continue to update. Get a little delay after that. If you set too long of an update delay here, I've heard that it can affect how it works. And sometimes if it's over 1500 milliseconds, which is 1.5 seconds, it can start to have issues. I think actually maybe anything over a second. But first thing is we're taking the temperature. We're pulling the carrier environmental read temperature, and that's getting the temperature, and we're reading it in Fahrenheit. My particular board was about 10 degrees off, so I had to set a negative 10 degrees for it to calibrate to about correct. And this next piece of the code is part of the loop for me that turns the fan on and off. So if the temperature inside the box is over 100 degrees, and this is sitting outside, so it's over 100 degrees quite often, it will turn that relay open, which turns the fan on. And this is actually wrong here. This should be valve off at 95 degrees. In the notes. And so the else if on this is if it's goes below 95, then we're going to turn the carrier relay 1 off. So carrier relay 1 close. Next section is taking the RFI. This is all part of the Wi-Fi Nina library, which is built into, I think, the actual Arduino IoT code. So, and it's pulling the Wi-Fi RSSI to be used later. And the next section is, this is if I'm going to use the sensor, and this has to do with the buttons. And this if statement is, if I'm using the sensor, then the integer raw moisture is being set equal to what we're reading off of the moisture sensor, which is the analog pin moist pin, which we set as I think A5 earlier. And then we're mapping this now to from 0 to 100% based on what we had pulled earlier in the calibration. So moisture is equal, or we're mapping that to the raw moisture setting, which is going to be somewhere between 0 and 4095, and the calibration that we set, which is air analog, which I think was 3000 something, and then water analog, which was I think 1600 something. And we're setting those to 0 and 100. And then the next if then or if else statement is to run the pump. So if the moisture sensor is reading less than 40% moisture, so if it's gotten dried out, then we want carrier relay 2 to open, and that's going to send voltage from the battery pack to the pump. And we actually have both a pump and then I have a valve that also opens. So the valve opens and the pump turns on at the same time. It's all from the same voltage. And then if moisture level is then greater than or equal to 70%, then it will turn the pump off. Let's see, carrier relay close. If use sensor is false, this is if I switch the button to false, then it's going to look for the other button, which is me setting the relay state to either on or off. So if sensor is false, that means I want to use the manual pump on and pump off button that's in the phone app or on the internet here. And that actually is here. So right now I'm using the sensor, so it's going to turn the pump on and off based on what the moisture sensor is. And if I want to turn that off and use it manually, I turn this off and set this relay state to on. That's how I manually turn on the pump, and then turn it off, and then go back to using the moisture sensor if I want to. As you can see right now, moisture is at about 70. These are live settings. Temperature is about 104 out there in the box right now. Wi-Fi RSSI is right around sneg 63. When I was having problems with this, it was at 80. So I was actually complaining to Arduino, and it shouldn't have been, when it was actually my own Wi-Fi signal from my Wi-Fi repeater. And this is the USB volt settings, which is at 3.4-ish right now. And I have a knockdown buck relay that turns the 12 volt coming from the battery down to a USB sendable voltage to power the IoT carrier. But anyway, back to the code. So anyway, like I said, if that is set to not use the sensor and then I turn it on, then this is reading, when I hit the button, it's opening it with the web button, or else when I hit the button to turn it off, it closes the sensor, or closes the relay and turns off the pump and valve. This is the analog read resolution. This is where I set this to 12 bits, so 0 to 495. And the integer sensor value, analog read A0, this is where it's reading the voltage for the battery pack. And that's a 12-bit as well, reading. And then USB volt, we're just setting that to voltage, so for the variables. And this is the analog read sensor for that, and that's just setting that down to 3.3 volts, which is what the board uses, is 3.3 volts. So I had the V out, V in set to those. And we're converting that all with this formula to the actual pack voltage then. And pack voltage is equal to the V in, which is from that formula. Carrier buttons update. This is the carrier buttons section. While the carrier light is color available, delay 5. This is just starting the carrier lights. And this is if the carrier button 4 carrier button on touch down. This is touch 4. This is the number 4 button. I'm filling the background screen to white. And then I'm setting the text color that will be overlaid over that background to blue for this one. And then I'm setting the text size to 4. And then I'm setting where the letters are going to show up on the screen. And for this particular one, 4th button is the RSSI setting. And we're setting what it prints on there to the Wi-Fi. This is the writing right here that it will show on the screen. And then the value that it will print, which is coming from that variable. So this basically is writing on one line, and this is writing it on the line, I think, after it, if I remember right. The next one, same thing. That's just for touch button 3, and we're setting the background to black. And for this one is the temperature, and we're setting the temperature text color to red, the same size text. And it's going to read temp, and then the actual value. Next one is voltage, and this is the pack voltage, and setting in the background to black. This is the touch button 2, and the actual writing to yellow for this particular one. And the this is actually allowing this to run to the next, and we're actually adding a V to that line, that second line where it's pack voltage. So we're going to read, 12 volts and then a V afterwards on the screen. Next one is the USB voltage, and that's, like I said, it's the USB voltage going into and powering the Arduino. And the last one is moisture. This is obviously the important one, but touch button 0, and background's black, text is white, text size 4, setting where it's going to be on, and we're just calling it moist, and then the percentage. These are the things that the Arduino code automatically, when you set a Boolean value, it adds to the end of the code. And this is just setting that it's on set relay state change and void on user sensor change. So I'm using sensor and the set relay change. And that stuff you can see, let me, if you open the full editor, this all shows up in the thing properties. And these are the settings for that. There's my secrets, which is here. I won't show you that because that's my Wi-Fi, but it's all set in here. And that corresponds with, in the setup, here when you set the network here, and that's where you get your secrets from. And here's the void, like I said, what they put at the end of the code. This is the onset relay change, onset sensor change, and those are also down here. It's the properties down here, set relay state, read write on change, onset relay change, and on use sensor change, and then the Wi-Fi connection handler for setting up the Wi-Fi connection. But that's basically it. And this is the code that I wrote, and it is working, and I like being able to manually turn it on and off now, and it's also nice to be able to see the RSSI on the Wi-Fi too. So if I move that box around and I move it somewhere where I'm not going to get a great signal, since I've changed all this, I haven't had any problem. You can see it's hooking up over the air quite well. And when you see it up in here, it's showing no associated voice device found here. I'm not sure why. I probably need to refresh. They've struggled a little with the, but there it is. Okay, it popped back on. You can see it's available for over the air. If I had it plugged into the USB port of my computer, you'd see an option. There would be a pull down menu here that would allow me to use over the air or whatever port that I was using, port 8 or whatever. And that's pretty much it. So this is the covering the code. And if you have any questions, definitely leave me questions in the comments. And if you enjoy this type of content, let me know, and we'll keep posting this kind of content. I keep refining this stuff, and some of our next projects are probably moving on to making a Arduino controlled mister for our patio, and that'll probably be my next project. I'm also doing a little more work on one of my 12 volt mobile solar generators. I'm switching out the little cheapo charge controller in it to my first Victron device, which I didn't end up being able to use for, I wanted to use it to have a little more control over sending voltage into my home office here where I power one of my computers with the tool shed. But it turns out they have some software issues with the load outs on the lower end Victrons, so it didn't end up working. So I've really liked the AppEver devices that I've had, so I'm going to stick with those. I think it seems to just keep working. They say it's not as sensitive for MPPT when it's pulling. It doesn't, on cloudy days, it doesn't pick up as much voltage as the Victrons, but it's working for me, and it works on Wi-Fi, so I'm happy with it, and we'll probably stick with those. I may try a larger, it's because AppEver doesn't have larger. We're going to build a 48 volt system to power our Lightning pickup truck and a air conditioner for my garage. And that will be one of the projects we do soon. We're going to add probably another 5,000 to 6,000 watts of solar to our roof, and that's going to be a separate system that's more or less off-grid that powers just the truck and the mini split that I'm going to get for the garage. But anyway, talk to you later. Thanks for watching.